Okay, so problem solving with sets is our last lesson in the sets and set notation section of this course. So this is taking some of the terminology and stuff that we've looked at the last couple days and putting it into practice, figuring out some stuff as well as a couple other diagrams that we're going to use. So we're going to start with this example. So we did a survey of 20 students showing the following data about movies that they had watched. So student 1 has watched both Tarzan and Grease, student 2 just Tarzan, so on and so forth along there. Okay, so we're going to look at, does this chart below actually represent the information, or accurately, represent the information, why or why not? So notice how there's 20 students here, and when I total all this up, 6 plus 13 is 19, plus 11 is 30, plus 2 is 32. So this is saying that there are more people watching movies than there are. So this shows 32 people instead of 20. So what's happened here is students are getting counted twice. Okay, so a better way to represent these sets of this set of data are these following two types of diagrams. So a Venn diagram, hopefully people have seen before. It looks like two circles that are overlapping. Okay, and because we now know that all of any items that live in a set are going to live in a box, we're going to do that as well. Okay, so we could classify this as Tarzan and Grease, and we could actually represent this more effectively with our Venn diagram. So the first thing that we want to look at is how many have watched both. So there's 1, 2, 3, 4, 5, 6 people who have watched both. So that's going to go in the overlap of our Venn diagram. The next thing that we want to do is only Tarzan. So we've got 1, 2, 3, 4, 5. So 5 is going to go in there. And then we want to know only Grease. So then 1, 2, 3, 4, 5, 6, 7. 7 is going to go in Grease. And then finally we want to look at how many have watched none. So 1 and 2. Okay, so now when we total up these numbers, 5 plus 6 plus 7 plus 2, we get 20, which makes more sense because 20 people were surveyed. Okay, what happened here is that Grease and Tarzan, the individuals, all of this overlap got double counted. So if we subtracted 6 there, we'd get the 7 that just watched Grease. And if we subtracted 6 there, we would get the 5 that just watched Tarzan. Okay. Another way that we can do this is what we call a Carroll diagram. So this is kind of a 2x2 grid, and we're going to go for either watched or did not watch both of these two videos. So the first thing that we want to look at is if they watched Tarzan and watched Grease, that's the same thing as that overlap. If they did not watch Tarzan, but they did watch Grease, that's that one. If they watched Tarzan but didn't watch Grease, that's this. And then if they did not watch either, that's 2. So again, 6 plus 7 plus 5 plus 2. Your number in a Carroll diagram or a Venn diagram should always equal the total number of people surveyed. So another example. So a class of 30 students were given, asked which of the activities they did over the summer. Their responses are given in the following table. Okay, so we've got 23 who said they went hiking, 12 who said they went camping. We've got 9 in that hiking and camping category, and 4 did neither. So the first thing we want to do is make sure that this data is accurate for the 30 people. So we do 23 plus 12 plus 9 plus 4. That's 48. So we've got too many. And the doubles, the overlap, are counted twice again. Okay, so the first two things that we're going to look at here is we're going to calculate the number of students who only went hiking. Okay, so this is going to be equal to the number who said they went hiking minus the ones who did the hiking and camping. That you can picture it as the overlap in that Venn diagram. So this is going to be 23 minus 9. So 14 students just went hiking. Okay, and then calculate the number of students who only went camping. So again, this is the people who said that they went camping minus the number of people who said they went hiking and camping, because we're getting that overlap there. So this is going to be 12 minus 9. So there's 3 people who only went camping and didn't go hiking. So we want to represent this data in a Carroll diagram. So that's that chart. So we're going to go hiking and no hiking across the top. Kind of make a grid for ourselves. And then camping and no camping. So according to this, there was 9 who went hiking and camping, so I'm going to put that in there. The people who went camping and didn't go hiking are these guys here, okay? So, these guys. So if they went camping but not hiking, that's the 3 students who we calculated who only went camping here. And then only went hiking, that's going to be the 14 where we have hiking but no camping. And then 4 are going to go in the neither category. So anytime we do this, we're going to go 9 plus 3 plus 14 plus 4, and we get 30, which is what we're supposed to get. Okay, and again, we can do this in a Venn diagram as well. So 2 different ways to represent essentially the same information. So we'll call this one hiking. We'll call this one camping. So we've got the 9 who did both. They live in both circles. Okay. We've got the 3 who went camping but not hiking. So there's that total 12 who said they went camping, right? And then we've got 14 who went hiking but not camping. So that gives us the 23 who said they went hiking. And then we've got the 4 who did neither. So again, those are the same numbers as up here. So we know that they equal to 30. Okay, so if we're given a Venn diagram, we need to be able to interpret that as well. So 50 students in a high school were surveyed about which of the lunches they had eaten. The data is represented below. So we've got pizza and mac and cheese. So if we add this up, we've got 16 plus 20, so that would be 36, plus 8 would be 44, plus another 6, there's our 50, okay? So if we want to know how many students ate pizza, we want to look at the ones who only ate pizza and the ones who ate mac and cheese and pizza, because they ate pizza. So we're going to go 16 plus 20, so 36 students did that, okay? How many students did not eat mac and cheese? Okay, so remember that the other word for did not that we can think of is complement. Okay, so if we look at everything that's outside the complement of that mac and cheese circle, these are the kids who did eat mac and cheese. And so everything outside of that would be the complement of the kids who did eat mac and cheese. So that's going to be 16 plus 6. So we've got 22 kids. The other way that we could think about is everyone, especially because this is the complement, minus the kids who did eat mac and cheese. So that would be equal to the 50 people that were surveyed, minus the people who did eat mac and cheese, so that's that 28. Oops, sorry, there should be a minus sign. So 28 So that's going to give us 22 as well. So either way, we should get 22 people for who did not eat mac and cheese. How many students ate pizza or mac and cheese? Remember, or is the union. So we're talking about either you ate pizza, you ate mac and cheese and pizza, or you ate just mac and cheese. So either or of the options. So we're going to go 16 plus 20 plus 8. So we get 44 students there. Okay, and then how many students ate pizza and mac and cheese? Remember that this and means we're looking at the intersection, so it means they had to do both. So that one's 20. It's that actual intersection in here. The next example that we're going to look at here is it gives us most of the information, but not all of it. So there's a little bit that we have to figure out here. Okay, so we have 28 students who were surveyed and asked if they ever had dogs or cats for pets at home. So we want to determine how many only had a dog or only had a cat. Okay, what these bits of information tell us or don't tell us is about the ones who have dogs and cats. So we've got 18 students saying they have a dog, 16 students saying they have a cat, and 4 students saying neither. Okay, now what that means is, so again, if we add this up, this is a total of 38 students, which is more than the 28 that were surveyed, right? So what I'm going to do first is figure out the total with a pet. Okay, you might want to write up in the margins here like I am, because we just want to make sure that you have enough room. So the total with a pet, if 28 students were surveyed, and we know that 4 don't have a dog or a cat, we know that 24 have pets. Okay, so that's the first thing that we want to think about. So if we start thinking about our Venn diagram, because I think it's just easiest to draw this information out. There's 4 people who don't have either a dog or a cat. And then the numbers in these circles should add up to 24. Okay, so we've got the total of dog and cat right now being equal to 18 plus 16, so that's 34. What we see here is 34 does not equal 24, right? 34 does not equal 24. We should know that, hopefully. So that's how we know that there is overlap here, okay? So to figure out our overlap, we're going to take how many students said that they had one or the other or both and subtract how many we should have had. So we're going to do 34 minus 24 is equal to 10. So that is our overlap. So 10 people, because there's 10 extra compared to what we have or should have had, that means that 10 people have both, and they identified in both of those 2 columns. Okay, so then we can use that number to figure out how many have just a dog. So that would be the 18 who said they have dogs minus the 10 that are in the overlap. And so that would give us 8. And then we could figure out just cats. That'd be the 16 that said they had cats minus the 10 who have both, so 6. Okay, and to make sure that we did this right, we're going to go 6 plus 10 plus 8 plus 4. This is 28, so there is our total. Okay, so we know we have done this correctly. Okay, our last couple examples both have 3 pieces of data. So now we're going to have Venn diagrams with 3 things overlapping. Okay, so when we have 3 different pieces of information, a Carroll diagram no longer works because it's a 2-way table. we've only got two, like we can only do rows and columns. You can't put a third dimension in that. So in these cases, we must use those Venn diagrams. Okay, so example, a veterinarian surveys 26 of his patrons. So whatever we put should equal 26. He discovered that 14 have dogs, 10 have cats, and 5 have fish. Okay, 4 have dogs and cats, 3 have dogs and fish, and 1 has a cat and a fish. If no one has all 3 kinds of pets, we're going to figure out how many patrons have none of them. Okay, we're going to use a Venn diagram to organize this information. So I'm going to actually do my circles first so that I make sure I have enough room. So we're going to have dogs and cats and fish, and we're going to make sure that they all overlap. So dogs, cats, fish. Now what we're looking for is how many people don't exist inside any of these specific categories, how many people exist outside of the people who have pets, the complement of the people who have pets, the ones outside. So we want to start, and whenever we can, when we're dealing with Venn diagrams, we always want to figure out what the intersect is, or like in this case, this would be the triple intersection in here, kind of in the middle of a flower looking thing. Then we want to figure out the double intersections, then we want to work out. So I'm going to essentially read this information backwards just based on the way that it's organized. So it says if no one has all 3 kinds of pet, that's actually meaning that there's a 0 in that middle overlap. No one has dogs and fish and cats. Okay, so we've dealt with that. 4 have dogs and cats, so we're going to put a 4 in the overlap between just dogs and cats. 3 have dogs and fish, so 3 have dogs and fish. And 1 has a cat and a fish, so that would be there. So we've dealt with all of that information. Okay, now we're going to go back and say, okay, if 14 people have dogs, that includes the people who just have dogs, but also the ones who have cats and dogs and the ones who have dogs and fish. So for just dogs, it's going to be 14 minus the 4 who have the overlap with the cats, minus 0, so we're not going to write that, and then minus the 3 who have overlap with the fish. Okay, so that's going to give me 7 people who only have dogs. And then we're going to do the same for cats and fish. So we know that 10 have cats, but that has to include the 4 people who have cats and dogs and 1 person who also has a fish. So we have 5 people with just cats. And then fish, we have 5 who have fish, minus the 3 who are overlapped with the dogs and the 1 who's overlapped with the cat. So we only have 1 person who has just a fish. Okay. So we're going to figure out the total who have pets. And that'll tell us how many of the people surveyed have pets. And then the remainder of that 26 is going to be the people who don't have any pets. So we're just going to add up all of the numbers in our Venn diagram. So 7 plus, and I like to just go clockwise around, especially, or I would start in the middle usually, but since that's a 0, so we can even write that. So 0 plus 7 plus 3 plus 1 plus 1 plus 5 plus 4. And that gives us all of our regions. Great. You could like kind of scratch them out as you go if that makes it easier for you. Either way, we add that up and we get 21 people who have pets. Okay. So the people who don't have pets are going to be the 26 that he surveyed minus the 21 who do have pets. So there's going to be 5 outside of the people who have animals, the circles that represent the people who have animals. Okay, so we can have those 3 bits of information and still categorize them and represent them via a Venn diagram. The last example is also a triple intersect, so the 3 different bits of information, and this one's a little bit trickier. So there's 79 grade 10 learners at school. All of these, so notice all, we should have no remainder. There should be nobody who doesn't fit into any of these categories. Take some combination of maths. This clearly is like an English problem because we don't call them maths, we just call it math. Geography and history, okay? The number who take geography is 41. So there's a bunch of information here. So the first thing that I'm going to do is I'm going to actually draw out my circle. So we've got, I'm going to call this one math, this one geography, and this one history. So there is our information there. So now I'm going to actually go and read this, and just because it's all kind of in this big paragraph, it's kind of hard to look at and find what we need. I'm going to start making a list to help me categorize my thoughts. So that might be something helpful for you. So the number who take geography is 41. So remember, that's going to include the kids who just take geography, and the one who takes math and geography, and the ones who take all three, and the ones who take geography and history. So geography total is 41. History is 36, and math is 30. Okay. The number who take math and history is 16. So we're gonna have, I'm gonna use that intersect symbol. So math and history is equal to 16. And so I'm using that the intersect symbol, that upside down U, to represent that. So math and history is 16, and the number who take geography and history is 6. Okay. Then we have a math only, 8, and a history only, which is 16. So those two we can fill in right away. Okay, so this is where this puzzle gets a little bit trickier because there's not any other ones other than the ones, the onlys that we can fill in right away. Okay, what I do know is that math and history, so where math and history overlap, so that would be here. This part has 16 in this whole overlap. So I shouldn't actually write that 16 there, because that whole overlap that includes the geography and just includes math and history is going to be 16. What we can do from that is, if we look at just the math circle, we know that 8 plus the 16, who are a combination of just math and history and math, geography, and history, plus whatever goes in here has to equal to 30, because it tells us that 30 people are taking math. Okay, so to figure out the intersect between math and geography, so math intersect geography, we can say, okay, there's 30 people taking math minus the 16 people that we know are taking math and history. So that's subtracting here. So we're gonna have, minus the 8. I was like, this number seems too high. So the 30 people who are taking math minus the 16 people we know exist here, and then minus the 8 people, that's gonna give us just the untouched part of this circle here. So 30 minus 16 minus 8 gives us 6, okay? And that can go in that kind of, it looks kind of like a petal to me, and the intersection of the petals. So if we want to figure out the union between geography and history, so that's here, we know that there's 16 people in this overlap. We know that there's 16 people who are just taking history, but we also know that there's 36 people total. So 36 total minus the 16 people who are just taking history minus the 16 people who are taking some combination of either math and history or all three. So we're just looking for this intersection here. So you can kind of just look at this history circle. That's going to be 4, and so 4 people are just taking geography and history. Then we can look at the fact that we had these 2 intersections given to us. So we knew that math and history, so here, had to equal 16, and geography and history here had to equal 6. So if this kind of upward shaping petal here has to equal 6, and we've already got 4, that middle number has to be a 2. Then if we know that this petal here, kind of up to the right, has to be 16, and we've already got 2 in there, this one has to be a 14. Okay, so it's kind of a process of elimination thing going on. Then for geography, we know that there's 41 people. So up here, there's 41 people total taking geography, minus the 6 who are also taking math, minus the 2 who are taking both of the other options, and minus the 4 who are taking the history. Now we're going to have 29 people just in geography. Okay, so when we add all that up, we're going to have the middle plus, and then I go clockwise starting from the top so I can keep track of which ones, 29, which ones I've done and which ones I haven't. When we add all that up, we get 79. So again, there was not supposed to be anybody outside of the circle. There was no remainder on this. So there is our kind of breakdown of the learners. So there was some puzzling to do here. So it's kind of like a logic puzzle built into our set theory stuff, where you have to figure out, okay, how can I use the information that's given to me to figure out how these numbers accurately go into these spots. So if you have any questions, let me know. You guys can be reading through the second lesson. I know this was the third one I did, but I broke the first one into 2. So it's lesson 2 in the set theory section of your SNAP book. So you guys can be reading through that and then doing the practice problems. It's listed on the bottom of your sheet, but it's not listed here. So again, if you have any questions, let me know.